Okay, guys, we'll just wait 2 minutes more, then we'll start off with the session.
Okay, ma'am.
Okay, guys, so we'll just start off with today's session. So today, basically, we will be covering polymorphism, like yesterday where we left. We'll continue from there. So we'll cover polymorphism, abstraction, and we'll see how to include that. And we'll go ahead with seeing some of the examples related to this. And accordingly, if we like after this, we do have time, we'll go on with the libraries, Python libraries. Fine. Guys, understood about today's agenda?
Yes, ma'am.
Yes, ma'am.
Okay,
Voice
fine.
is little broken,
So
ma'am.
I'll just, okay, there is any issue now, like related to my voice? Is it audible properly?
Ma'am, it is breaking.
Totally breaking?
Yes, ma'am.
Okay, okay, let me just reconnect. Just allow me a moment. Now, is it fine? Is my like the voice is okay to you?
Yes, ma'am.
Yes, ma'am.
Okay,
Yeah, ma'am.
okay, great.
Yes, ma'am.
Okay, fine. So I'll just share my screen. You people let me know whether it is visible or not. Fine. Visible? My screen is visible to you?
No, ma'am. Yes, yes, ma'am. Now it's visible.
Visible, right? And my words are clear? Like it is audible to you?
Ma'am, it is audible, but it is quite breaking.
Yes, ma'am.
Okay. Like actually in between, I am like there is certain issue with my voice actually. Like I am having a fever and having issue with the vocal cord, so might be like I cannot speak that up. So like is it related to that issue or the network issue? Can you please confirm?
Ma'am, I think it is related to
Network issue,
network.
ma'am.
Network is on.
Ma'am, now it's
Network issue.
clear, ma'am.
It's ma'am.
Okay, okay. It is clear now for everyone.
Yes, ma'am.
Yes,
Yes, ma'am. Now it
Okay,
is.
Yes, ma'am.
okay, okay, great, great. Then we'll just start. Okay, so today we will be starting with polymorphism. So, in simple words, what polymorphism means. Okay, so what like it is a Greek word polymorphism. So poly generally what poly means? Poly means many. Okay, and just a minute. Okay. And a morphism, that is forms. So it in combination, you can say polymorphism, like it is one thing but having many forms, right? Understood?
Yes, ma'am.
Okay, okay. Just a minute. Let me just write it for you so that it becomes easier for you to understand as well. So screen and voice all clear, right? You are able to hear
Yeah,
me
yes,
and
ma'am.
also screen is visible. Okay, okay.
yes,
Just a
ma'am.
minute. Yeah. Okay. So as mentioned, polymorphism, it is a poly that means many and morphism that is forms. So polymorphism, we can think it of one thing and many forms, right? So let me just give you an example. So you can think of like it's we can think of polymorphism using the same method or function name, but the behavior is different. That is technical way I am saying. But in terms of when we are thinking of a real life example, we can think of the word suppose drive. Okay, so we can drive a car on a road, right? We can definitely drive a boat or sail a boat on a on water. Even we can like drive, we can like the word is similar, so we can drive a plane also that is flies in the sky, right? The word drive is same, right, but the actions are different. Right, guys, understood what I'm trying to say? The words are the word drive is same, but the action is different depending on the object. Like when we are say calling it as for car, so we are driving it on a road. When we are calling it like driving a boat, if we are considering this, then we are actually meaning we are sailing a boat on a water, right? Similarly, when we are thinking about a plane, so we are thinking about a plane that flies in air. So the object is different. So here the object is car, boat, and plane. But the word, the drive, that is the action. That is same for all of the three. Right? Understood, guys?
Yes, ma'am.
Yeah, ma'am.
Okay, okay, got it, fine. So basically, when we let me just show you the collab file. Yes. So we generally like last sessions also we have seen in the code we generally use self, right? So why are we using that? So that question I forgot to answer last session. Like no one also questioned, so I didn't answer that as well. So let me just answer for a better understanding in that part. So whenever we are creating a method like function inside the class, like suppose I am putting class here, suppose class animal, inside it we are creating a function, like we are creating a method in total. We need a way to refer to the same object, like the object itself actually. Okay, so the same object itself, so that is the one that we are actually working on. I am calling like us like referring to that very object. So we need a way to refer to the object itself. So that's why in that position we use self. So that's where like the self comes in actually. So self is like how we can say it? Self, it is like this object, this specific object where you are working currently. So that signifies, that self signifies. Okay. So it allows us the access, like the access of variables, also the methods that belongs to the current object that we are working on. Okay. So that is the reason we are using self. Okay. So there might be situation where we can use, like, let me just write a code for you in case of self. So we are using, sorry, class dog we are using. So inside it, we are using def, init, self, command name I am putting. Sorry, just a minute. Yes. So inside it, what I am writing, self dot name I am putting equal to name I am putting. This I don't need. So this is how I am creating it up. Okay. So if I need to create a dog class, suppose I am putting, suppose here I'm right, putting another code like dog one equals to dog, and I'm putting the name of the dog as okay, it has came it like that. I'm putting it like that. So it is running. So what it actually, so without the self, Python won't know which dog's name we are actually talking about, right? So without the self, which dog's name I am specifying up here, that is not understandable. That's why we are using this self. Okay. So next we can come on to an example of polymorphism. So we'll create a base class. We have actually created a base class here that is animal with two child class you can see. Like it is dog and cat. Like it is in the form of inheritance we are going. But here we have created a base class with two child class. One is dog, another is cat, and each with their own specific speak. The speak function is different for each one. Like for dog class, it is different. For cat class, it is different. Okay. So I am just writing this code. I have just written this code up. So what actually I am doing up here? So we have created, like defined a class named animal, and we are thinking it as the blueprint. Like it, we are defining it as a blueprint of all the animals. We can think it of like that. Inside it, we are defining a method that is speak, and we are using self. Self here means this specific animal object, this specific animal object. Okay. So here we have created this animal class up. Next, we are going, what we are going? We are doing class dog. So class dog, we are creating a new class of dog we are creating that like inherits the properties of animal class. So dog, animal, we have put it. Animal means dog inherits from animal, like its own type. Its type is from animal class. Okay. Then we are using this def function, like this new version that is speak for dog, where it overrides on the animal one. Like here we have raised non-implementation error that is basically related to, since we don't know how it sounds basically in that form you can think of, we just wanted a return, like just a return or default message we just want to return. So that's why we have raised this. Next, when it came according for dog class, it is actually providing us going ahead. We are just overriding along with that. Overriding over like over in animal class. Similarly, in case of cat, we have created another class that inherits the property of animal class, and we have again override the speak method up here and return what meow. So, and now what we are doing, just like we have gone ahead and created dog one equals to dog, like creating the object and like based on dog in the previous section in this here, here also we are doing the same. So here we are trying for the same and we are running a loop here for animal in animals, like the loop for each animal in the list will count it up. And now we are printing animal and how it speaks. Like for each object, we are calling the speak. So if it is a dog, it would print like boop. If it is a cat, it would print meow. So when we have just run the code, we have got it like this. Okay, so this is how we have got it. So based on this, we can conclude like this is an example of polymorphism. That is, we can think of like one thing, but many forms we can think it of. Since we have overridden here this self method, this speak method multiple of times. So here we are getting an example. So similarly, there is another example that you can see similarly bird, but here we haven't considered up with better formation or better way to check it on. Like we haven't inherited anything. It has worked separately, and while we have done like the similar way, we have gone it through, and we have printed the output up. Okay, so this is what polymorphism is actually. And then going ahead with the init. Init is basically a special method in Python class. Okay, so it is like it is called automatically when we create an object for a class. We are just creating it automatically. So its job is basically you can say is to initialize or set up the object which is has its first value up. Its work is like that. Okay. So understood what I told by now? Is it clear,
Yes, ma'am.
everyone?
Yeah, ma'am.
Okay, fine. So in object-oriented programming, that is OOPS, a constructor, as I told, that is this init, is a special method that creates the object. In simpler form, you can think it of like that. That in object-oriented programming, a constructor is a special method that actually constructs or create a object. Okay. So in we generally use this underscore underscore init underscore underscore. This is actually the constructor. Okay. And going ahead, this is the form we are like, this is the way we are just writing it up. So there is a double underscore, which means like the, which means it is a built-in special method, you can say. It is a built-in special method. Okay. So in this case, we are going ahead with an example for better understanding. So here we have gone ahead and defined a class. The name of the class is dog. We have created up and we have defined like this is the constructor basically this part where we have taken three arguments inside it. That is the self, that is the actual object like itself the object of itself, name and the age. So self will always be there. Like you don't need to like you don't pass it, it will always be there. Okay. So in this case we are putting self dot name and we are going equal to name. So it what it does, it stores the given name inside the object. So in this section what it does, we it stores the given name, whatever the name be given, that will be stored inside that very object. Suppose, like here, when we have created it off, we have given the name Tommy, right? So it will get stored inside it. In self dot name, here this name will be Tommy name will get stored, right? Then what in the similar way we have created the other form like dog one. If we can consider it as in the form dog one here, you can see so what it does, dog one equals to dog Tommy cross comma. What would be the age? We have put in 3. that creates a new dog object specifically. Okay. And the Python runs the constructor in this format because I need to print it in this format, like print dog one comma named comma dog one comma age. So the name and the age will be printing side by side. So similarly for the dog two we have created and we have run the code. So this is actually what instructor is doing up here. Okay. So in the key form, we can think it of like that. It runs automatically when we are just needing or creating a new object. It runs automatically. Okay. So we used to set like in this form, we can say that we use it. It used to set the initial values of the object, whatever be the initial values that is there. It is needed to get in through the object specifically. Okay. Understood?
Yes, ma'am, clear.
Guys, understood? Okay,
Yes,
fine.
ma'am.
So, what happened when we are not using this init? Okay, without init, what we are using? We are using, like, we are going ahead and doing the same class dog we have used, we have passed, given dog one equals to dog class we have called and print dog one, right? So, when we are writing the code, we are getting this as output. So, why we are getting this? Here, object exists. This object actually exists, but they don't have any useful information inside, right? That's why we use this init that initialize them properly, and we do get the information that needs to be there inside that very class. So that is the specific reason we are using this init. Okay. So next we'll move into abstraction. Okay. So abstraction, anyone have any idea about abstraction?
Yes, ma'am.
Yeah, tell.
Ma'am, abstraction, it means that hiding internal details of something and showing only the
Right.
essential features. Like you said yesterday, the example of remote, like
Right.
the how things are working, that is hidden, but that is hidden. And for users, the buttons are there to control the remote. That is abstraction.
Yeah, exactly. Exactly. So abstraction, as she told, abstraction means hiding the initial details or the internal details specifically and showing only the important features or important information that is needed. So in Python, abstraction basically what it does, it's let us focus on what an object does instead of how it is doing. Right? Understood? Understood, guys?
Yes,
Guys,
ma'am.
can you please respond? Okay, great. So in a real time, we can think of suppose you are driving a car, right? So you just press the accelerator to move forward, right? So you don't need to know how the engine actually burns or how the engine get actually accelerated, how the gear works, or how the pistons inside are moving. These details you don't need to work, like you don't need to understand actually. So you press the accelerator, you move forward. That is the basic criteria that you know, right? So the internal details, how the things is working, that is not required for you to understand. So in simpler sense, you can just think of about where while you are driving a car, you can think about accelerator, brake, steering wheels. That will help you out to run the car, but not you are not known about the internal details, right? So what? Why we are just needing abstraction? So as we know, in abstraction we are hiding the complex details for the user, right? So why we are needing? Because it makes us easier. It is very like this makes the user experience easy when if you are going ahead and just focusing on driving, that is more important, not how the engine fires, what are the pistons working. That is of no use for your case, right? So that is not required for your case. So we just need a useful and easy user interface. So that's why we are generally using abstraction, and it does focus on high level operations. We don't need to focus on any low level of code also, because we just think focus on the high level operations, the internal details, internal intricacy. We don't have to see much, right? So we need to just go in deep about any of the examples. Okay, just a minute. Yes. Okay, so let me just go ahead with this example. So here we are doing from, like, as we know, like we need to have like import basically. So we have just imported the abstract class, abstract base class. So that is ABC. That is from ABC module, we like small ABC module. That is a module that has been already created in Python. So we are just creating this abstract base class, that is capital A, capital B, capital C. That is the form we are using. And abstract module or abstract module methods basically. From abstract module, we are just importing the abstract method. Abstract method defines what abstraction is, but not implement in the parent class. That is not required for us. That's why we have just imported them. Okay. So going ahead, what we do, we have just imported it up. Next, we have included a class. The name of the class we have used vehicle. Okay. So we created an abstract class basically here. The name of the class is vehicle. And in the bracket, we have used ABC, which means that this class is a special type for abstract base class. This is a special kind of class that is an abstract base class. That is the very first step we need to cover. Okay. Next, we will go into the second step where we need to define the abstract method. What abstract method we are basically converting on. So at the rate abstract method, this one, yes, this one, what we are doing, this this is actually decorator marks that the next method of like that tells us about the next method as abstraction is coming up. That is the base thing. So then next we are just starting off with this like inheriting the vehicle class, that into the implementing to this method we need to start. So here we have def start. We have just started off. So here we have def start. Like since that very part we are importing off, so we are just creating the start, and it only defines the rule, not the actual behavior. So we just passed it off. Like no implementation we are doing, only rules that are there that is being defined up here. Okay. Next, we are creating a class. The name of the class we have created as car, and it inherits from the vehicle class. The vehicle class that we have previously created, that has been inherited in this class actually. Okay. Then we are creating the same def start against self. So it actually, since the car inherits the properties of vehicle, it must implement the start method, right? Otherwise, the Python will show a error in this section. So that's why we are just using it up, and we are returning that the car engine starts with a key. That is the return. That is car specific implementation of starting, right? So that's why we are creating it up. Next, we have gone ahead for bike. Similar way we did whatever we did for the first car section, we have did for bike. Bike starts with a button. So this is how we have created. Now we need to call it up, like we create the object basically, and then we need to go ahead. So car one equals to car, that creates the object for car, and for that we are printing car one start. So how it is starting, we need to print that. So we need to call the same method, like for the start method, that for different object, we are just calling it up. Okay. And same for bike that we did. So similarly, it is getting printed. Okay, so this is an example of abstract. So abstract class can have both abstract method, that is the no implementation session, and the normal methods also. You have seen, right? That is here no implementation. Basically, we have just passed it on, and next also we have this implementation part, right? So we cannot create a object of the abstract class here. We haven't created the object of this abstract class. We have created the like the object of car and bike that we have created, that we have actually created up here, and we have just called it up. Okay, and abstract class basically helps in creating the common interfaces that is needed for different classes. So that is the exact work what abstract class actually does. Okay, so this is how we have, similarly, we have taken another example in the similar form. So we have created the abstract class for payment where we have passed ABC. Next, this is the abstract class basically. Next, we have created other two specific class, that is credit card for payment, and we have returned like what is the amount, like how it would be paid, and what is the amount using credit card. This is what we want to return. So similarly with PayPal, we have already created another class. Then we have created the object for the specific, like for payment one we have created and printed it accordingly. So we have got like this output, like paid 500 using credit card, paid 1,000 using PayPal. Okay, so clear, guys, clear? This much clear?
Yes, ma'am.
Yes.
Okay. So, okay. So there are two things that we generally come across, that is abstraction and encapsulation. So there we do represent a similar thing, like we are hiding some of the major details, but there are certain specific difference that is needed to be concluded up in both the section. Like both are different. It's not like both are similar thing we are doing. So in abstract class, what we are doing, we are hiding the implementation details. Whatever be the implementation details that is running, we are hiding that and showing only the essential features. Okay, so what we are doing basically, we are focusing on what the object does, and not how it is doing. What is the proceedings of doing that, and that is not mandatory in case of abstract class. We are only focusing on what the object is doing. Okay, so for that you have already seen, like we have used that abstract class, the ABC module. We have used the abstract method. We have specifically used. Right. In case of encapsulation, what we are doing, we are wrapping, like binding the data, that is the variables, and the method, that is the function, into a single unit of class. Right. In a single unit of class, that means we are controlling the access of data specifically. Understood what I'm trying to say? So we are hiding it using like private or protected variables. So that we are not doing in case of abstraction. So where is the major difference, you understood,
Yes, ma'am.
Yes,
guys?
ma'am.
Everyone?
Yes, ma'am.
Okay, fine. So, in case of encapsulation, what we are doing, we are just defining the class. We are using the access modifiers, like the public class, like how can and where it can be accessed, then the protected or private form, and then going ahead basically. So here, let me just give you an example. Yes, here we have an example. Just a minute. Yes. So here is an example specifically related to this, related to encapsulation. What we are doing here. So we are creating a bank account. So it defines the class. The name of the class we have given as bank account. So the class is actually the blueprint of making the object, right? So under it, we have gone ahead and done def, init, self, and balance we have used. So init, as I said, it is a special method that we are doing. and Python runs this automatically. When we are creating this bank account, it runs it automatically. Then balance, what balance is? Balance is a parameter that we have passed accordingly. So when we are creating the object, so we need to check the initial amount on the account. So for that, this balance we have actually created. So this balance, what we have did, that self dot balance, after creating this, the self dot underscore balance, this underscore balance, this we have used as balance. So this create an instant attribute that name is underscore balance that sets it equal to balance. That is the value that is passed in. Okay. So this self-dot balance that belongs to that particular object, which each object that we are actually created, that is underscore balance, this part actually. Okay. So this actually is been created and we have used it in the, like, we wanted it private. That's why we have created it in the private section. Then we have what we did, we gone ahead with the deposit section. It defines a method that belongs to the class of the previous class, that is bank account class. It has been gone ahead with. Next, we have passed on self and amount we have passed in. The amount is the money that has been added to the account. So we went to a bank, we deposit certain amount, right? Then we need to check the balance up. So here we want that is get balance. This specific features. This defines the method or to read the current balance that I am actually having. So this often sets into the getter format. So this actually returns self dot underscore balance. That is this private. So what we did, we just skip off this section. We have kept this private. We don't want this to get into consideration. We just combined it or binded it all together and formed in one section itself. But my actual want or need in this section, that is get balance, where I am getting what is the actual balance is there in my account, right? So this is the major difference between encapsulation and abstraction. And then we generally know how to use oops, right? But there are certain methods where we can like omit using oops also. Like that is not specifically needed. We don't need to use oops. But that is time consuming. Why we are needing? We will be performing the same operation in code with oops or without oops, and you can get to see the difference. So here what we have taken, we have gone ahead with balance equals to 500. So we have just initialized it. We have stored the initial account balance. You can think it of like that. Initial account balance we have stored, and only account can exist like based on that only we have taken into that. Like balance variable we have taken and we have initialized it. Then we have gone ahead like function, like we have taken this function def deposit this amount. Then we have gone ahead and created global balance. Since balance is outside the function, we need global to tell Python that is use this just you can tell that use this variable in this format, you can tell it off. Then balance plus equal to amount, it adds the actually the deposited amount. And then eventually we have the function to check the balance, that is get function we are going ahead with. And then we are just calling it what is the deposit we have done and what is the actual amount. Previous amount was 500 and deposited is 200. So in total, it would be 700. So this is how we are doing it without oops. So now let us try and do it with oops. So it would be more methodical, more balanced, and also more segregated. Like you are getting it in a proper segregated form, so that each step is easier for you to understand. So eventually, what we have created up here, similarly, we have created the bank account under itself. We have created that is init self and balance, that is the constructor, and which runs automatically. Then we have created like self dot balance against balance, like each object for balancing its own balance, like getting its own balance, we are created it accordingly. Then it will automatically update the account balance. Okay. So for that, we have created it. Then we have created another method, that is deposit, for what amount of money being deposited. Then what we performed all of the operations there. Then going ahead, we have created to check balance, like get balance. This operation we have, this method we have called on, and there the intention is to check the balance. So while we have done all of it, see how much well balanced it is, how well it has given me the output. So for every deposit we have get, like the current balance is this, how much it is, what is the deposited amount, what is the new amount we have gotten, then what is the current amount we have got after this initial. Then after this, what is the, for the second case, what is the initial amount, then what is the deposited amount, what is the new balance, what is the current balance we have got. So it is more structured, and using OOPS is more beneficial to be to come into place. Right? Clear, guys?
Yeah, ma'am, right.
Understood?
Yeah, ma'am.
Yes,
Okay,
Okay.
ma'am.
okay. Okay, fine. So we can think of like with OOPS, it is easy, and we can use multiple objects at the same time. But without OOPS, it is harder because we don't get that form to correct it up in the upper section. In the code only you can see, right? Because we don't have the access of the variable that is state outside. We need to call global. We need to state Python that it is global, and we have to call that, right? So that is the stuff we need to do up here. But here, see how structured it is. We have created the function. Accordingly, we have gone ahead with created this method up. What specific method for deposition? We have created a separate method. For checking the balance, we have created a separate method, and accordingly we have just created the objects based on those accounts. Specifically, we can think of specific, if we are considering two different account or three different account, we are creating it like that, and we are calling it down, right? So in that form, we can see like the data manipulation, or in case of encapsulation and privacy, it is there in case of OOPS. But in case of like when we are doing it without OOPS, there is we can't use this encapsulation, privacy, or data. This type of stuff we cannot use in without OOPS. And we can reuse this code in case of you, like in case while we are going ahead with OOPS, reusable, it is also scalable. That is very easy to do all of this in case of OOPS. And it also gives us a high maintenance. The maintenance is very easy. Like in this case, the maintenance is very easy. But without OOPS, it is very difficult. And it is a high maintenance, like it is high maintenance because based on each of the steps, we need to check it accurately for each of the steps, what step we have actually gone ahead with, what are the details we have think it of. So this is how we need to check it off. And also the functions, like we need to use global in each of the form when we are defining any of the variable outside the function. But in case of OOPS, it is everything inside the class. So we don't need to put in through. Clear, guys? Everything is clear?
Yes, ma'am.
Yes, ma'am.
Any question related to it?
No, ma'am.
No, no, ma'am.
Okay, fine.
No, ma'am.
Okay. Okay, great. So we just have 5-10 minutes left to end the session. So today we are not going ahead with the libraries, or not plotting through how it's actually the plots will be, or how interactive plots we can create. I am not going into details with that. In tomorrow's session, in details, we will be seeing how we can just go ahead and do a proper like uh, how we can using matplotlib, seaborn, how we can use interactive plots that we will be learning in tomorrow's session. And actually, we will be trying to build, like, we will definitely work with the data tomorrow. If after we are done with this plotting part, like understanding basically, then we will be going ahead and plotting, like get the data from Kaggle or any of the well-known source and try to do a project up here, maybe in the form of a simple EDA analysis we will be doing. And if possible, I'll like try to give you any of the reference of my project, what template I use, how to present it in front of a stakeholder, or the details that I will be showing in tomorrow's session. Okay. So as
Okay,
of
ma'am.
now, any other
Okay,
question
ma'am.
related
No,
to it?
no,
Any
ma'am.
other question?
No,
No
ma'am.
question?
No, ma'am.
No, no.
Okay.
No, no.
Okay. Okay. Great. 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 So let me just check any offer letter thing. So based off offer letter, you will be receiving. It will take some time, but you will be getting it. Or any query you are having related to the offer letter, you can directly mail to the HR. Okay. So they will help you out related to this offer letter stuff. Okay.
Okay, ma'am.
Okay, ma'am.
Yeah. So I guess you have that mail ID, like HR's mail ID. So you can
Yes.
just drop the text, like mail up there. They will definitely guide you through. Okay.
Okay, ma'am.
Okay, fine, great. So we'll just end, like wrap up our session today here. So I hope everything is clear, because these things would be needed when you'll be writing the code. Suppose in this case, when you'll be going ahead doing any of the EDA project also, these things will be needed up when you'll be working with the data, right?
Right.
Yeah,
Okay.
ma'am.
Great. So we'll just stop today here. We'll meet tomorrow and we'll, as discussed, whatever the details we have discussed, like whatever the agenda I have discussed for tomorrow's session, we'll be
Okay.
doing that. Fine?
Okay, ma'am.
Okay. Okay. Yeah.
Thank
Thank
you.
you,
Bye.
ma'am.
Thank you.
Thank
Thank
you.
you, ma'am.
Bye-bye.
Ma'am,
Thank- Yeah. Any question?
ma'am, we do not receive any offer letter, ma'am.
That's what I told, right? Aren't you there in the class when I was telling that related to offer letter, I am not the person to tell. So you just drop a mail to the HR. I guess you are having the details, like the mail ID of the HR. You just drop a mail there, and your session just started. I guess this is the third class, third or fourth class. Can anyone tell me, this is the third session, third class or the fourth class?
Fourth.
Fourth class, right? Okay, so this is the fourth class, so it will take some time. Don't worry, you'll receive the offer letter. Fine.
Okay, ma'am. Thank you,
So
ma'am.
by the time, if any issues related to that, you can definitely drop it off.
Okay, ma'am.
Okay. Okay,
Okay,
fine.
ma'am.
Okay. Yeah. Bye then.
Bye, ma'am.